Yeah, okay. Thank you so much for the introduction, Anna. Yeah, I'm very excited for today's event. I think it's very important to know what is the opportunities and what is the important things related with the quantum and avian quantum and obviously in Qiskit. So yeah, basically the things I want to share is kind of similar, but focus more in my experience. And well, combined it with ABM because well, we're part of the ABM too, right? So that is the goal here. So basically the thing is like, yeah, I'm a computer science focus related in quantum computing right now in optimization problems and quantum machine learning techniques. But initially, my thing is like, I don't have any idea about quantum computing, but I was always curious with physics and computer science. So this new area, it was pretty interesting for me, how it's working, what is the new things, what is the characteristics, so my first thing is like how we can work with quantum computing or what is the things are important in quantum computing instead of using a classical like GPUs, TPUs, FPGA, or these different dedicated components to use a powerful solution in certain problems. So the first thing I learned with quantum computing is we can reduce certain polynomial problems. Well, it's not polynomial, sorry, and a polynomial time. But the interesting thing is not all the problems are necessary to use in a quantum computer. And one learn of this one is like certain problems or complex problems related with the nature, like chemistry, like optimization, and multiple things where can I find a similar thing in a quantum computer and make more easy. So the interesting thing of this one is like not everything will be quantum. Is certain problems where the limitation is complicated. Quantum computing will be necessary. It could be yes, but in a certain cases, or what is the characteristics. So the interesting thing I learned during my career in quantum computing is like we need to think what is the difference problems like electrical fan batteries save the save the information for certain things in chemistry designs different sensor for components in the industry in general from healthcare for research for different topics astronomy in general or reduce or identify the benefits in the vehicle or in the reduce for like vehicle routing problem like it's a real cases for certain cars airlines or what else. So basically the thing is like we need to think in the complicated things. That is the chip we need to think. At the moment working in quantum computing is like yeah, it's important to recreate everything in quantum, but the most important thing is the complicating ones. So the goal here is like nature is quantum, so we need to simulate everything in a quantum way. So the potential of the quantum computing is like just think in different ways, different possibilities, and that is the thing I think is important at the moment we are working in quantum computing is like why using quantum? What is the difference? What is the characteristic? It's a new paradigm, it's new rules, new characteristic, but they make more simple ways the complexly things like what is a Hamiltonian or what is like to do a neural network. Basically, quantum computing is matrix and vectors, and the basic example for a neural network or artificial neural network is a matrix multiplied a stack vector where we are the data sets and we have 10 certain decisions. So basically the thing we're doing here is kind of similar and the complicated things we're doing right now in quantum in classical computing, but in quantum is more simple, more nature, and we can try to do it. So the thing is like, yeah, classical computing has certain problems and quantum computing is how we can avoid, how we can find different potential things we can unlock the limitation we had in in the classical computing and say yeah quantum computing we can find a utility. So basically here is like we had interesting problems for the general problems, but after then we can find a utility is like reduce the time, reduce at the time, the memory, and obtain at least the same solution or a better solution and we have right now in the state of the art. The state of the art is the best solution we can find right now in a classical computing and using all the techniques in a quantum computing for a specific use case. So the thing we need to remember right now is quantum computing is not necessarily using like a calculator or focus on video games or sense everything or found an easy way to recreate video games or like the GPUs, more quality in the videos. It's more found a complicated problem. We had a question is like, oh, this take a lot of time. It could be possibility for the society found a solution for these ethnic problems or reduce for this specific problem a benefit. That is the goal. So that is the pretty difference we need to find at the moment working in quantum computing is not all the cases. It's just the cases we found with the properties we got it with quantum computing, superposition, entanglement. We can identify it's possible or no. Or the moment to recreate a geometry like for the molecules in the characteristic for a Hamiltonian, that's possible because the quantum computing we have different characteristics. It's a sphere, the qubit. So we have the axis X, Y, and Z. So we can recreate geometry position, angles, characteristics. So we can identify in those cases many things. What kind of case or what is the characteristic were important here? Is chemistry, optimization, machine learning, and numerical simulation. Because of the areas in the industry we're thinking is aerospace, automotive, chemicals, superconductors or electronics, energy, finance service, and healthcare of life science. So at this moment, we need to identify everything of these areas are possibility in a general way, but are focused in a certain limitation we got in the classical computing. Like for the finance, like portfolio optimization problem, at the moment we can invest in a certain budget of the money we got it, or identify or accelerate products development in chemistry, or identify the iCrash computational fluid dynamics. So everything is a limitation. We got it like, okay, this is complicated. So why need a quantum computer? Because the complicated thing we can reduce the potential with the quantum computing compared with the classical one. So, like in the previous introduction about Qiskit, we had certain things. So, like Qiskit is a SDK, and we had an IBM quantum computer. So the idea is connect both things to found the utility scale work. So the thing for here is quantum must be performance, but must be easy to use. So focus in this area is like when we try to identify quantum computing, previously we were just focused with Qiskit or Qiskit runtime, but recently it's like exist different partnerships in IBM when we had to create or use the powerful for certain Qiskit function, where is the black box, where they recommend they solve certain characteristics, so initialize certain things for optimization, for simulation, for numerical simulation or for mitigation. And the things are cases like using Qiskit case, Qiskit add-ons, and Qiskit transpile or Qiskit runtime just to make certain processes in the quantum computer more flexible and easy to use. Because it's simply, yeah, Qiskit SDK is simple to use, but the thing is like we need to recreate different process like the compilation, transpilation, the quantum circuit, the mitigation, the error correction. So basically, we need to think again in circuits. Like it's the low level in quantum computing. It's like the ensembler level for quantum. So basically, the things we are doing right now is identify a problem, a real world problem, and translate in terms of quantum circuits and operators or gates. Try to reduce the problem of the number of the gates physically in a simple case because everything in the computational way we can optimize. And in this case, when we have an error process, the best thing is reduce the resource. So that is the thing. And the third one is execute. If we are interested in identify the probabilities, the expectation value, or the energy in a specific way for the problem we need to identify, and do the post-processing to reduce the error or make more simple or optimize in a nice ways the problem we got to identify and see is working or not our problem. So basically, the workflow we have right now is where the science and general problem in the real work, use Qiskit library, identify what could be the circuits and the observable. The observable is what is the characteristic or the interesting thing we need to do it. And after that one is make always optimize in the characteristic for the hardware we are working because not all the hardware are the same. If you are in the Quantum platform, we had multiple hardwares, or at least three in the open access. Like say before, we had now 120 minutes for now 1 year. So depends on the hardware, we have certain characteristics and different physical positions, so not always had the same solution. And the next part is like we need to optimize the pen of the hardware and try to execute. And after that one is how we can evaluate it, if it's work or no, exists the Qiskit add-ons, or we can reduce the noise. Yeah, everything is free and we can identify multiple things, multiple libraries. So yeah, quantum computing is a bunch of different libraries, a bunch of multiple things. But the interesting things we can find what is the thing by thing. So the thing or the important part I need to remark here is like in my case, I possibly understand everything, but I don't know everything. Exists other people who understand one area, one specialization. So no quantum computing means you need to understand everything. You need to specialize in one specific area or topic, and it's important to understand general workflow of the pipeline for your problem when you try to do research, but it's not a mandatory. So the special things about this one is like exist different people, different roles in quantum computing, even in IBM when we working in this case, and the benefit they make more easy for me, like in the research area, identify a solution, in my case, in optimization problems. So basically, in avian or general in the quantum ecosystem, exist different quantum software, SDKs, and KPUs, and exist different people, different roles in all this area to make more simple for us create a useful solution. So if you're interested or you have certain characteristics or knowledge in those areas, is a good step start to do that. Yeah, the first thing, I'll say, oh yeah, we can work in quantum software general, not necessarily focus in Qiskit because exists Qiskit add-ons, ecosystem tutorials, demos, or focus specialized to optimize the hardware, wherever. There exists multiple things, multiple roles, and everything are necessary. And most important, this kind of events, everything is truly necessary to make more noise in the ecosystem and say, yeah, it's possible. Yeah. So I need to mention what kind of things, in my case, I just focus in quantum computing more in events, activities, workshops. So I don't know in my PhD specific how is working quantum computing. So my goal right now in this section is mention quantum computing you can learn. Exists a lot of communities, a lot of events, and I've been support of this one. So it's like you have certain roles, you can still working in deep in quantum computing and you can do it. In my case, I learned my first event or my first interaction in the world. It was the Qiskit Global Summer School in 2020 when it was the COVID time. So in this case, IBM now has certain course, sort of basic levels for different aspects, and it's for free if you had an account. So I recommend just do it and create, and you can find this kind of website and start to do it the different course. Because in my case, when I doing my PhD, I be part of the Qiskit Advocate programs too. I participated in the Qiskit Global Summer School. Even I got the Qiskit certification. And when I did an internship, I was part of the seminar for the Qiskit YouTube channel. So in my case, you told me how still working or how do my transition in the academia for the industry in avian quantum is practically everything related with quantum in avian. So I make everything, I contributed, I be part of the Qiskit Summer School like a student. The last year I was one of the designers for one lab. So yeah, basically I think the community is so important. I'll learn. I met a lot of people online to support me to be more involved in quantum computing. So that is the nice thing. So I truly recommend Qiskit Global Summer School is the best thing if you are still working in quantum computing and see the new things we have in ABN or in general, this is the way. Qiskit Fall Fest exists an event in, well, yeah, during the summer is the registration, but it's in the fall where you create your own hackathon workshop or create your community when it's in a school or university, general or country or a continent or around the world on an event, you can do it. Actually, the first time in 2021, I did my first hackathon with the Qiskit Fest. So I take all these opportunities, be a student in summer school, organize my hackathons. I be part of the internship in 2023. Even I don't use this because you can see my face in the middle, but it's the nice photo they take. So yeah, even if I'm not working in IBM, you can see my face during promote this kind of internship. So it's the nice things. I was in that moment, I was a Qiskit advocate. I organized hackathons. I worked the challenge for IBM Quantum, other hackathons for different communities and companies. So in that moment, it's like it was everything online. My first time to meet people related in quantum computing, it was in the internship. So basically, you can create a lot of things, a lot of characteristics, events, or communities online. And quantum computing is the best moment right now to create more events, more participation because everything is free. And even like let's say we had a certification and create a groups and you can support in the Qiskit Advocate program, create more groups. Actually, I'm part of the Qiskit Advocate squad from IBM. So if you participate and you did this course I mentioned before and certain knowledges, you can even apply to be part of the Qiskit Advocate program. And we had networking events, and you can find more people like Anna, and we can create more connections. You can see or listen to more events or connect with people who has certain experience in different levels in different part of the world related with quantum computing. Um, yeah, apply for the mentorship program and it's free. So imagine you had certain knowledges and make relation with a lot of people in the in ABN, in quantum computing, and it's not necessarily with ABMers, it could be with other people. Actually, I know a lot of people for this kind of events and they don't work in really in ABN quantum or ABN in general, but yeah, it's pretty nice how people were connected and you can see different paths for different people. And yeah, it's pretty awesome for that one. And yeah, that is my presentation.